Welcome students. This is 10th standard mathematics for Cbse students and we are going to see algebra in which we are going to see polynomials. Before getting into the subject, let us see what is the meaning of the word polynomial. So, poly means many. Poly means many. Nomous, the meaning of which is arrangement. Arrangement, order, law, rule. So you can so these are all the meanings of the word nomous. So poly means many, nomous means arrangement. So many things are arranged, and for your information, in English every word can be broken down into Greek roots or Latin root, and meaning can be found out. Okay, so when you literally, if you want to know the meaning of the word polynomial, many terms are arranged, many things are arranged. Okay, but this is only etymological meaning. So from the viewpoint of etymology, this is the meaning. Many terms are arranged. Now we will see what is the meaning of a polynomial. What is the meaning of a polynomial? Okay. Now, before going into the actual polynomials, into the syllabus, any expression of the form, say f of x, let us call this as f of x, expression as f of x, and that is equal to f of x is equal to an x power n plus an minus 1 x to the power n minus 1 plus and so on, plus a2x square, or rather a3x cube plus a2x square plus a1x plus a0. So is called a polynomial. Is called a polynomial. Instead of saying f of x, you can say p of x also. A polynomial in the variable x, variable or unknown x, variable within bracket unknown x or indeterminate x. So this is the general definition of a polynomial. So how many terms are arranged? See, there are so many terms arranged, more than 2 terms are arranged. So they are all arranged in accordance with their powers, and we say that what we have to do is, these are all coefficients, an minus 1, a3, a2 and so on here. So where the terms are rather an minus 1, an minus 2 and so on, a3, a2, a1, a0, they are all called coefficients. They are called coefficients, and these coefficients can be, you can take it from, they can be real numbers. These coefficients can be real numbers. They can be real numbers. a1, a2, a3, all of them. a0 and so on. an, they are all real numbers. Or they may be rational numbers. These coefficients can be rational numbers. Or they can be integers also. They can be integers also. Of course, for 10th standard, they cannot. These three number systems is enough for 10th standard. These three is enough. Okay. So the coefficients can be. Now we are going to introduce a term called the degree of the polynomial. So if you look at the general equation of polynomial, namely p of x is equal to a n x power n plus a n minus 1 x to the power n minus 1 and so on, a3 x cubed plus a2 x squared plus a1 x plus a0. If you look at the general polynomial, this we say this is a polynomial of degree n. We say that this is a polynomial of degree n provided the coefficient of x power n should not be 0. Coefficient of x power n should not be 0. So I am going to put what? So if I say it's a polynomial of degree n, if I say p of x is a polynomial, so we say p of x is a polynomial of degree n if an, the coefficient, is not equal to 0. Now what is of degree n? Of degree n. So what is degree? Degree is the highest power term is what is called degree. Highest power term is what is called degree. Highest power term is what is called degree. So degree of the polynomial is the highest power term. And for this polynomial to be of degree n, the corresponding coefficient should not be 0. Corresponding coefficient should not be 0. Now we will give examples of polynomials. Okay. Now we will give examples of polynomials. Okay. Now let us look at the examples. What am I going to do is, now let us example 1. A simple example. Example 1. Now what do we do is, let us take all the coefficients to be 0 up to a2, a3 and so on, an, all these are 0 except these two. Except a1 and a0, all other coefficients are 0. So what will happen? I will write p of x is equal to, this is a1x plus a0. That is from the general polynomial, by making all the coefficients except up to a2 0, you take only these two which are non-zero. a1 is not 0, a0 is also not 0. You take these two. What is the degree of this power? Degree of the power of x is 1. If the power of x is 1, then we say that it is a linear polynomial. It's a linear polynomial. So for this to be a linear polynomial, what is the condition? Linear polynomial or a polynomial of degree 1. Polynomial of degree 1. So for this to be a polynomial of degree 1, the condition that we should have is a1 is not equal to 0. a1 is not equal to 0. a0 may be 0, no problem. But when you say degree 1, the corresponding x coefficient should not be 0. So this is an example of a linear polynomial. Now you can give a1 and a0 any value that you want. So let us write the polynomial. Say for example p1 of x is 5x plus 4. So this is one example of a linear polynomial. P2 of x is 4x plus a0 is 0. a0 can be 0. So this is another example of a linear polynomial. So like that, p or q of x is 1 by 2x plus 5. 1 by 2x plus 5. So degree of the polynomial is 1. So in all these are all examples of what? Linear polynomials. And let us give one more example. F of x is equal to minus 5x minus 4. So it can be negative. Coefficients can be negative also. Coefficients can be negative also. So degree of the polynomial should be here 1. Degree of the polynomial should be 1. And when you say, as I said earlier, the degree of the highest, power of the highest term is what is called the degree of the polynomial. And remember that the degree of the polynomial can never be negative or a fraction. It should not be a negative or fraction. For that matter, you can say that n belongs to natural number. It can be either 1, 2, 3 or it can be 0. So it is a non-negative integer. The degree should be a non-negative integer. So this is one example of a polynomial. So this is the general linear polynomial, first degree polynomial or linear polynomial, linear polynomial. So we gave one example of linear polynomial, and these are all examples of linear polynomial. Okay, these are all examples. Now look at the degree. Degree is 1. In all the cases, degree is 1. 1 is greater than 0. In all the cases, degree is 1, which is greater than 0. Now, from here, we give an example of a quadratic polynomial. Okay. Now, example 2. Example 2. What is the example 2? Look at this is example 2. Now, what do we do is, from an to a3 up to a3, let us make all the coefficients be 0. From a1 to an to a3, 0. Now let us take these 3 terms, namely, let us call that polynomial as what? Q of x, that is equal to a2 x squared plus a1 x power 1 plus a0, a1 x power n plus a0, comma, a2 is not equal to 0. a2 is not equal to 0. See, when a2 is 0, what will happen? It will become a linear polynomial. So 0 into anything is 0, then it will become a linear polynomial. So for this polynomial, for q of x to be a quadratic polynomial, the degree of the highest term, namely x square, the coefficient of x square should be not 0. Should be not 0. So a2 is not 0. So this is a quadratic polynomial. This is a quadratic polynomial. See, all the polynomials we can get from here. Polynomial of any degree can be obtained from here up to n. N can be any degree. Only thing is n is a non-negative integer. Non-negative integer. So this is a quadratic polynomial. Now what we are going to do is, we are going to see more examples. For example, q1 of x. q1 of x is x square minus 5x plus 6. So this one is an example of a quadratic polynomial. Look at the degree of the polynomial, 2. So when nothing is given, the coefficient is to be taken as 1. So degree of the polynomial is 2. Likewise, you take q2 of x is 5x square minus 16. So this is another example. Here we have x square term, but we don't have x term. That is possible, that is allowed. Only thing is the coefficient of x square, namely 5, which is not equal to 0. Which is not equal to 0. This is another example of a quadratic polynomial because degree is 2 in both the cases. Likewise, q3 of x. q3 of x is one more example, which is x square plus 2x. Here the constant term is missing, but still it is a quadratic polynomial. So quadratic polynomial can be any of the 3 types. Any of the 3 types. Okay. Only thing is, for the polynomial q of x to be not equal to 0, the degree of the highest power, the coefficient of the highest power is not equal to 0. So a2 is not equal to. So this is an example of a quadratic polynomial. This is a quadratic polynomial, and these are all examples. Now what are we going to do is, we are going to give example of cubic polynomial. So which we take it as what? Cubic polynomial. So what is a cubic polynomial? So example 3. Now up to before a3 you take all the coefficients to be 0 and a3 is not equal to 0. So what I am going to do is, let us take h of x to be a polynomial, which is a3 x cubed plus a2 x square plus a1 x power 1 plus a0. So for this polynomial to be a cubic polynomial, the condition that we have to put is a3 is not equal to 0. So a3 is not equal to 0. So this is an example of cubic polynomial or general form of cubic polynomial. General form of cubic polynomial rather. Now by giving different values to a0, a1, a2, a3, we get different examples. For example, h1 of x is x cubed, 2x cubed. All other coefficients are 0. So this is one example of a cubic polynomial. And h2 of x is 2x cubed plus 5x square. So this is another example of a cubic polynomial. So h3 of x is x cubed plus x square plus x. So this is also a cubic polynomial because the highest degree term is 3. And finally h4 of x is x cubed plus x square plus x plus 1. So this is also an example of a cubic polynomial. So for because the degree of highest degree is 3 in all the 4 cases. So this is examples of cubic polynomials. Now we are going to give one more. We are going to see one more example and we stop. Okay, what is that? That one is example 4. So that also can be obtained from here, starting from a4 and a5. All other a2 a5 all the coefficients are 0. Start with a4. So x to the power 4 plus a3 x cubed plus a2 x squared plus a1 x plus a0. For this to be a polynomial of degree 4, the condition that we have to put is a4 is not equal to 0. a4 is not equal to 0. So this is a biquadratic polynomial. A biquadratic polynomial. Bi means 2, quadratic means 2. So 2 times 2 is 4. So degree 4 or fourth degree polynomial. Right? By giving different values for a4, a3, a2, a1, a0, you will get different examples of the biquadratic polynomial. So this is the star equation. This is the important equation. General expression for a polynomial. General expression for polynomial. And we say that it is a polynomial of degree n, provided this n is an is not equal to 0, the coefficient is not equal to 0, and the degree of the polynomial can never be negative or fraction. Okay, can never be negative or fraction. And the coefficients of the polynomial an, they can be either real numbers or rational numbers or integers. Now we will give non-examples of polynomials, expressions which are not polynomials. Okay, expressions which are not polynomials. Example 5. So let us take f of x to be and f of x to be square root of x plus 1. This is not a polynomial because this is x power half plus 1. So degree cannot be. Degree should be for a polynomial, for an expression to be a polynomial, the degree should be a non-negative integer, but here it is a fraction. Likewise, g of x, if you take g of x 1 by x plus 5, so if you write that, so it is going to be x to the power minus 1 plus 5. So this is not a polynomial because the power is minus 1. Here the exponent is minus 1, which is not allowed. So this is also not a polynomial. So for an expression to be polynomial, the powers, all the powers must be non-negative. That is, they must belong. They can be either an integer, positive integer, or can be 0. Okay, it can be 0. Now let us give one more example. Now you take a polynomial p of x to be 5. P of x to be 5, and this you can write it as 5x power 0. So this is a polynomial of degrees because x to the power 0 is 1, provided x is not equal to 0. Any non-zero number to the power 0 is 1. Any non-zero number to the power 0 is 1. So whenever you are given 5x power 0, namely 5, and this is a polynomial known as constant polynomial, constant polynomial. Constant polynomials are degree 0. So constant polynomial or a polynomial of degree 0. Polynomial of degree 0. So polynomial of degree 0 are constant polynomials. Polynomials of degree 0 are constant polynomials. You may be asked in one word question, what is the degree of a constant polynomial? Immediately you say that the degree of the polynomial is 0. Okay? Now, having said about constant polynomial, what we have to discuss is an interesting polynomial known as zero polynomial. Okay? Let us take an example, q of x to be 0x square plus 0x cube, or if all the coefficients are 0, an minus 1, all the coefficients are 0, then that polynomial is what is called a zero polynomial. And what is the degree of the zero polynomial? Degree of the zero polynomial is not defined. Okay? Degree of the zero polynomial is defined. So is if all the coefficients, suppose if I write a1x square plus a2x square, a1x plus a naught with a1, a2, a naught, all of them are equal, then it is going to be 0. So if it is 0, I can write x power 10, or I can write 0 times x power 100. Anybody can write any degree, because anything multiplied with 0 is going to be 0. So if it is 0, if when you multiply 0 with anything with 0, you will get 0. Any number with 0, you will get 0. So if it is a zero polynomial, degree is not defined. So what will happen if it is a zero polynomial? It's a zero polynomial. Q of x, if q of x is equal to 0 is a zero polynomial, then its degree is not defined. Degree is not defined. So remember, we have to remember two things now. If a polynomial is a constant polynomial, it is of degree 0. If a polynomial is a constant polynomial, it is of degree 0. If a polynomial is a zero polynomial, its degree is not defined. So this is what is introduction about the polynomials. Okay?